All right. It's going to be actually a pretty easy day for you. You're not going to need a lot from me. Traditionally, I give you guys a summer reading packet. And you guys are getting a huge gift this year. My summer reading packet is a 30-page, 34-page long. It's like the size, it's even longer than your review sheets for exams. And it's just nothing but formulas. Some of which you know, some of which are new. And you would learn those things. And today, well, our second day of school, traditionally, I give the first 40-point quiz. And I give a whole bunch of them the whole first 9 weeks. And it just decimates people's averages. Usually the class average on the first test is like a 47%. And then the class average on the next one's like a 70. And then it eventually works up. And I always drop the lowest. And if you make an A on the last one, I drop the second lowest. So it normally works out, but since and it's all math team kind of stuff, a lot of math team kind of stuff, because there's a really decent chance we're not going to math tournaments. I don't know how there's no way they can put 1,100 people in a building, especially with like all those 7th graders running around, and they'd be infecting the heck out of everybody. So we can't do that. So there might be an online state tournament. They have talked about that, but we would not be going anywhere. We would be doing it here. So like I would set something up in the pod, or maybe we'd use 2 pods because there's a lot of us. And you guys, if they can get this down, you might just log on and do the math and log in your answers. And I would monitor you, and it'd be an honor system thing, which I don't know. I mean, I'm honest, but I know some people in the past have not been. So we'll see. But anyway, I'm not doing summer reading because I need those days. I have this sneaky suspicion that we're going to end up losing stuff, and I don't want you guys didn't even learn probability and statistics last year. I cut out some other things too that we're going to be talking about that I meant to get to yesterday, but we'll have time to talk about today. Just a lot of things we missed, and it usually on the front end it's like, sweet, I don't mind doing that extra work, great. But at some point it catches up with you, and you're a little crippled for it, and I don't want that to happen. So I'm getting rid of the summer reading. You don't have to worry about that at all. But that's what I normally do today. And then just say, hey, here's a review of lines for tomorrow. So if you look in your book, if you flip to the table of contents, and you look down, and there's a lines functions review worksheet. And is that right? Yeah. So functions and their graphs, page 17, and then the lines review sheet, also page 17. There should be like a front, back, front, back. The first front, back is talking about lines, equations of lines, the different forms of lines. And y'all seeing this? Yeah, and if you read through that, you're like, oh, I know how to find slope. And maybe you forgot about the difference between point slope form or standard form, things like that. There's a great review on this. Historically, everybody just reads that. Normally, you wouldn't have time in class because we would be taking this summer reading, but you don't have that. So today, what I'm going to do is go over the things I wasn't able to get to in the video from yesterday. I'm going to finish up those topics, which will probably take me 10 minutes, and then I'm just going to let you start working on this. And I know it's weird being 7 or 6 or whatever feet away from each other when it comes to, like, hey, normally when we have review days, you guys just pull your desk together or get together close and start working. Don't hesitate to yell across the room. Like, I mean, if you want to be talking to Narcissa in the back, just say, hey, don't worry about the volume. Don't worry about all that kind of stuff. Volume's never really been an issue with you guys anyway. You guys have been on the quiet side in the past, somewhat. At least you were in second period, you know what I'm talking about. Y'all were extra quiet last year. But anyway, feel free to talk and do your thing, and don't let the distance barrier be a problem, because you're more than likely going to have some time today. And I'm going to leave the video on the whole time for you guys at home, but there might be dead time if nobody's asking me questions. So if you see me up here, you can put it on, get that playback speed up, and just run through it, and I'll answer questions up here if you have them while you're working on your review. But more than likely, you're going to look through here and you're going to go, this is not a big deal. So if you flip that first page over, the second page just gives you practice problems. And honestly, a lot of people just start working on the practice problems, and if they have trouble, they just refer back to the notes. But make sure you look at little things, like a lot of people think they know what standard form is, for instance. Like, do y'all remember what standard form of a line is? Who can tell me? Throw it out there. Okay, and that's great, but there's more to it than just that. First of all, it's important that the C is on the right, okay? But also, it's important that you know that the A, B, and the C, if it's really in simplified, nice standard form, what do they have to be? They got to be integers, okay? All right, well, you could say whole numbers, but integers include the negatives also. But it can't be fractions there, can't be decimals there. Now, that doesn't mean that you're not going to see something like this. Okay? You're going to see equations like that. They're just not technically in standard form. So if you end up with something like this, you'd want to multiply through by a 2 and get it to something that is actually standard form. So remember, no decimals, no fractions. Well, all of that I'm talking about in this review. So just make sure that you understand those things. Or slope-intercept form. What does slope-intercept form look like? Y equals mx plus b. Are there any conditions on what m and b are? No. In fact, m and b are forced to be whatever it is when you get that y to have a value of 1. But every year I see people simplify this and they leave it like 2y equals. It has to be 1y. And then whatever you get over here, you get over here. But those forms I'm discussing in there, and honestly, these two forms are fine, but point slope is the form that AP Cal loves. So point slope, you remember, is y minus y1 equals slope x minus x1, right? Y'all remember point slope? And this is great because if you have a point, you throw it in. You have a slope, you throw it in, and then you leave it. You don't have to, unless the problem specifically tells you to put it in a certain form, leave it. I have people still to this day, they put it in that form, like on the AP review tests. They put it in this form, and then they try to change it to either slope-intercept or standard, and they make a math error. And guess what? AP Cal gives you credit for what's right, gives you zeros for what's wrong, averages the two. So say it was worth a point to get the line. They're going to go, oh, +1 for plugging it in there. Oh, +0 for putting it in a bad form, if in case you make a careless error. And then they average it, and you end up getting a half a point. So you literally lost a half a point because you were trying to do too much. Don't do too much. If somebody asks you for an equational line, that is great. If they say an equational line in a certain form, well then do it. Or if it's multiple choice, and you need to change the form to see what answer's right, great. Y'all with me? Okay, so really, I think you're going to be fine on that. But I do want to talk about the things that I was not able to get to yesterday. And I also want to ask, are there any issues or any questions you have on what I was talking about yesterday as far as all the little bitty legalities? Was everybody saw the video? Everybody's good with that? I want to go ahead and apologize. I made the video out for Friday, posted it. I was like, oh, I wonder what it looks like. And I was actually using VidGrid. I don't know, VidGrid's a pretty cool program where you can actually just record your screen. So I got a little bit of talking, a little bit of writing. And I went back and listened to it, and the volume is atrocious. Like, you can hear me, but there's this squealing in the background. Well, after I did that, I started playing around. Again, I've got this new computer that I haven't been able to use much because this is my old one. Because I haven't been able to wire it. I need a 60-foot HDMI cord. And we used to run off these big, ugly, whatever, screw into the back of the computer VGAs. And I don't have it yet, it hadn't come in. So I was playing around last night, and the video is gonna sound terrible. But I figured out why I was screwing it up after I recorded the 30-something minute video. And I was on the wrong, I was using the volume from my document camera, which is horrible, instead of the volume or the speaker from my computer. So I'm going to apologize ahead of time for the video. It's going to drive you nuts, the squealing in the background, but it's going to be one and done. From here on out, my videos will be very clear like they were yesterday. Even if it's with VidGrid, you'll have nice volume, nice picture. It should be good. All right, and then also periodically, I might look at the camera and talk to my virtual people. I'm trying to get the virtual people to follow along with the red group. So I won't have to do that a lot in here, but sometimes I will. We have 5 people who are completely virtual the whole time. And there were not many teachers, I think I said this yesterday, but there were not many teachers that asked that Usually if somebody wanted to go virtual and they didn't have a class, they said too bad. But for some reason, for Helmers and I, they said, oh, can you do it on the side, which is really, really hard on us because now we have, and it's really kind of unfair to you guys because they're going to be at home taking a kind of test that you guys will be taking in here, and you know how it is. I mean, you can pull your notes out. And they were telling me, well, you should just get a camera and watch them. I'm like, dude, I'm clever enough to set my notes up behind the camera. I mean, kids aren't stupid. And then I was just whatever. So they're going to get a different test than you guys. They might get an essay question, you know, on stuff. I might not ask them for the work. I might say, hey, show me the process or explain to me why this even works. So they're going to get a totally different world. Try not to go virtual if you can stay in here. Keep your mask on so you don't get tossed. I think you'll learn better here, maybe. But even though you're only here a couple days a week, but anyway, we'll see. So no questions on all the stuff I talked about yesterday? Y'all are good? Sure? Okay, so here are a couple of things that you may or may not know. All right, so I think I talked about symmetries and tests for symmetries. Did that make sense to you? If it didn't, let me just give you an example. Like, sometimes I'll give you an equation and you'll look at it and you'll go, I don't even know what that looks like. If I gave you this and said, do you think it has symmetry? Well, you guys know what this looks like, right? This looks like a parabola starting at the origin. And you can just, well, that's not symmetric, but if I had a decent graph, yeah. Like, you would look at this, even without this picture, because you know what that is in your head, you would go, oh yeah, it has y-axis symmetry. But the check for symmetry, if you remember, is I could take something like this, replace the x with a negative x, and then if I simplify it, and these two things look the same, y-axis symmetry. So for y-axis symmetry, you replace the x's. For x-axis symmetry, you replace the y's with a negative y. And for origin symmetry, and this is, guys, this is if you don't know what the graph looks like. For origin, what do? You do both. So let me give you an example of that. What if I gave you this? Anybody have an idea what that looks like? I don't either. I'll tell you, it's that did we get to the, no, we haven't, that's this year. There's something called the pesky xy term. If it just has x squares and y squares, it's most likely a conic. You know, you saw conic sections when they both had x squares and y squares, and if I move that over there, I'm adding the x squares and y squared, so it's probably an ellipse. It's a circle, perhaps, if the coefficients were the same. If you forgot all that, don't worry about it. But this, with an xy, I have no idea. It could be all manner of things. So if I asked you about symmetry, you could go, well, let me just start checking the symmetries. So if I wanted to check y-axis symmetry, I could replace my x's with a negative x. And then when I simplify, do I get the exact same thing? I don't. Can I make it be the exact same thing? Like, could I multiply through by a negative and it look like this? No. So it is not y-axis symmetry. Well, let's check for x-axis symmetry. For x-axis symmetry, I would do that and then clean it up. Sorry. That becomes positive, so it stays negative. Does that look exactly the same? No. So it's not x-axis symmetry. And by the way, because we deal so much in functions, things that have x-axis symmetry aren't really discussed a lot in here, but it might be discussed in calculus, so I'm throwing it out there so you know to check. But probably not a lot with that as we move through the year. Now, check the origin symmetry. On origin, what do? Both. So check that out. 3, negative x, negative y, quantity squared, negative x, quantity squared. Both negatives go away. That stays, or that becomes positive. Sorry, that's mine. That becomes positive. That becomes positive. And what do I see? Origin symmetry. So what this means is I have no idea what that graph looks like, But I know that if I nail down the origin and spin it 180, it'll look exactly the same. Are you with me? So that's that check for symmetry that I really didn't get a chance to explain very well in that video because we ran out of time. But that's what we're looking at there. And then even and odd. Do y'all remember even and odd functions? I might have mentioned those, but I know that even and odd was really wound up in trig. And trig was the end of the year last year. And I skipped some stuff. So if you're like, I don't know what an even and odd function is, don't worry about it. Here we go. So an even function, the real nice thing to remember quickly about an even function is if it's even. Now I don't mean if it has an even power. Sometimes those are even also. But an even function always has y-axis symmetry. Right? Well, not right. You might not know that, but that's true, and vice versa also works. So if you know what the graph looks like, and you're like, wait a minute, I know what that graph looks like. It already has y-axis symmetry. Then you know it's an even function immediately. So if I gave you something like this, and you're like, man, I have no idea what this function is, but you look at it and you see y-axis symmetry, then you know it's an even function. Okay? All right, now, here's your definition of an even function. And I'm going to see if somebody can blow my mind and tell me in your words what this means. Here's your definition of even. Now, without just reading that, what do you think that implies? Okay, I'll give you a hint first. What do you think x and negative x is really saying? Opposite x values. 5, negative 5. 4, negative 4. Negative 10, positive 10. You following me? What does f of x mean? The y value that comes from plugging that x in. What do you think f of negative x means? The y value that comes from plugging negative x in. So what do you think this is saying? If I start with opposite x's and I plug them in, what do I get? The y's are the same. Does that make sense? Opposite x's, y's are the same. Now think about what that means graphically. Check it out. I'm just going to do a random example. Opposite x's, y's are the same. Opposite x's, y's are the same. Opposite x's, y's are the same. What do you end up seeing when that happens? A reflection of the y-axis. Even functions always have y-axis symmetry. This is a big deal in AP Cal, and honestly, I don't know why, because it's not calculus, but AP Cal has this obsession with even and odd. They love to just ask random questions. Oh, I may or may not have said this because I know I missed it in some classes. Your classes will, your desks will always be clean, I think, because Miss Austin comes in here and sprays every desk down. Which, Merry Christmas, you got a clean slate. However, in other classes, if they're like me, I mean, I'm an old school ADHD guy, but I was never medicated, and I have learned to function over the years. It was rough in high school. My dad was in the military. He was a colonel, and he didn't take that kind of forgetfulness. Once I forgot to empty the garbage, I came home that night, and the big giant green garbage can was in my bed made up. That was his way of, and I'm like, dude, seriously? It's funny, but I'm like, that was pretty, I mean, as a kid, was like, that's pretty clever. But I just forget stuff. So other teachers do too, and they have said, hey, try to wipe the desks off. Man, I've got 500 things running through my brain this year until I get this down. I'm not even thinking about it. So if you are really concerned about having a clean desk, those are probably sitting out, those tubs with the pull-out wipes. Just grab one, wipe your desk off. They ordered 5 bajillion of those. Feel free to clean up or whatever. And also, if you're suffocating, which you're probably not yet, although I'm already feeling it. Like I was sweating like I already am. Get out of here. Go take a breath. Literally. Go out of here, walk outside, breathe, and take a breath from me. because I haven't gotten used to this yet. So I'm going to be very flexible. I want to treat you guys like adults. If you're struggling, heck, you might have respiratory issues and you're really struggling to breathe. I know I normally don't. I have a great resting heart rate, great lung capacity, but right now, I'm like on 80%. It's not fun after having that COVID stuff. So if you're struggling anyway, feel the freedom to go take a break. Go to the, I've actually gone to the bathroom. I'm like, I mean, you hate to be in the bathroom taking deep breaths, but I mean, whatever you got to do it to survive all this, all right? And don't feel bad. I don't even have the bathroom passes. I can't have anything community. So just go, I got to get out of here. And feel the freedom. I mean, don't abuse the privilege or I got to figure out something else, but whatever. Are y'all with me? Okay, so you need to know this. AP does stuff like this. Hey, if f of x equals f of negative x, then, and then they give you this big problem. And if you don't recognize that this means, oh, it's an even function and it has y-axis symmetry, you're not going to get the answer. You won't. Because or they might give you half the picture and say, hey, f of x equals f of negative x, and they'll only give you this part. But then they ask you something about a negative x value. And you're like, well, how am I supposed to know that? Well, you're supposed to deduce that this means even. Even means y-axis symmetry. And then you got to think, oh, so if they ask me about f of negative 2, I know that that f of negative 2 is going to have the same value, y value as that f of positive 2. So they sneak that kind of stuff in on you all the time. I don't know why it's important. It doesn't seem like that's calculus, but they do it a lot. And it usually is like 5 points out of 108 on an AP test. It's a bigger deal than it should be. All right? Now, odd functions. A little bit trickier. Oh, maybe. Odd functions always have origin symmetry. Always. All right? And if they always have origin symmetry, and that's true either way. So if you know what a graph looks like, right? So if you looked at a graph and you're like, wait a minute. And you saw that and you went, oh yeah, that's one of those. If I nail it down right there at the origin, the true origin, not the shifted origin, but right there, and I spin it 180 and it looks exactly the same. If you know that for certain, then you know that it's not only an odd function, but it also has origin symmetry. And if you're wondering, well, what's the deal with the x-axis symmetry? Well, those aren't functions, are they? Right? If it has x-axis symmetry, what does it not pass? The vertical line test. So we're not even going to talk about those. There's no, because we're only talking about functions, we don't have to worry about this x-axis symmetry having a correlation there. Now, let me ask you a question. If right here, opposite x's opposite x's, same y's. What do you think is happening here? Opposite x's, like 2 or negative 2, have what? What? Opposite y's? How do you think I write that? Opposite x's have what? How do I write opposite y's? Put a negative on one of the f's. So technically I could put it on either one, because if they're opposite, then if the y values are opposite, then I would have to negate one of them in order for them to be equal. Does that make sense? That's how you write odd. Occasionally you'll see that negative over here, which is fine. I can multiply both sides by negative. But normally you see it like, normally you see it like this. F of negative x equals negative f of x. Maybe not normally, either one of those. That means odd. Now any other thing just means something else. I don't know, it just doesn't have a formal name if I throw any extra negatives on here. But that's what odd and that's what even are. If you didn't know, if you think about trig functions, can you think about which of your trig functions were even? Do you remember that? I think I did mention that, but maybe not. Think about the, is it the sine? Man, it's rough only working with this window. I got this brand new board. It's 16 feet long. It's the biggest board in the building. I can't go beyond the window until everybody's back in the building. It stinks. I feel hamstrung, whatever. Sine curve. Even, odd, neither. What's it look like to you? That's not a great picture, but odd, right? Opposite x's, opposite y's. Now, if you go, wait a minute, these opposite x's are the same. Yeah, but they're 0. So couldn't they still be opposite 0 and negative 0? Right? Opposite x's, opposite y's. Sine is odd. What about cosine? Remember how where cosine started? Now this is if there's no shifts. Not every sine curve is going to be even. Only sine curves that hit right there at the origin. If I shift this a little bit, just a little, then it's not even, it's not odd, it's nothing. Most of the time, functions are not even and odd. What about cosine? Where does it start? A basic old cosine, like y equals cosine x. Y'all remember? Yeah, that's what Open Notes does for you. I know. Those are the holes in your cheese. We got to fill those in. Cosine. Your algebra cheese has been weakened. You got to plug all those up. Remember cosine looks something like that? But what do you see here? Opposite x's. What? Same y's. Opposite x's same. Opposite x's same y's. Even function. What about tangent? That's just the middle part of tangent, but what does that show you? Odd function, origin symmetry. Y'all seeing that? Now, I just remember cosine is the only even one, and it's reciprocal, and its reciprocal of cosine is secant. Awesome. Do you remember the sine, cosine, tangent? And then cotangent, secant, cosecant. Sine and cosecant are reciprocals. Cosine and secant are reciprocals, and tangent and cotangent. So if cosine, if you just flip it, all the cosine ends up doing is looking, remember the secant graph kind of looked like that? Y'all tracking with me? It still has that y-axis symmetry though, doesn't it? I'm sorry, it still has the y-axis symmetry. So the only two even functions, assuming I'm not doing any crazy shifts or something like that, or any shifts, whether they're crazy or not, are cosine and secant. Everything else would be odd. But most of the time when I shift it, I lose all my even and my oddness. Couple of other things. And this is more of a math team thing. I doubt you'll ever be asked this in anything but this test. But anybody got a guess of what happens when you add an even function? Oh, I tell you what, I'll talk about something else. How about this? An even added to another even. That'd be something like an x squared added to a x to the 4th. What kind of a function do you think you end up with? Still even. And you can see that pretty clearly because if I plug negatives in there, like this is an even function, because if I plug a negative, I square it, negative goes away. I'm back to what I started with. This part's an even function. If I plug a negative in there, raised to the 4th power, negative goes away, I'm back to where I started. Adding two of them remains even. You follow me? Same with subtracting them. Remains even. What about odds? An odd plus or minus another odd. Let's check it out. Here's an odd function. Remember the x cubed kind of looks like the John Travolta or whatever, if you remember Saturday Night Fever. Whatever. You remember?
Sure.
It's an old movie from the 70s. It's kind of cheesy and dumb, but anyway. John, you know who John Travolta is, right? Okay, yeah, from like Pulp Fiction or whatever. John Travolta, he was doing a disco movie, and he had this pose. I have the album. Anyway, but we used to call it the John Travolta in the 90s. Everybody still remembers it in the 90s. Now it's been 40-something years. But anyway, that's what the x cubed graph looks like. It's kind of like the middle of a tangent. Kind of looks like that too. But the x cube's odd, right? Origin symmetry. What if I add it to another odd function like I don't know, 5x to the 5th? Now, how do I know each individual one's odd? What happens if I plug in a negative in there and cube it? It becomes negative. So an opposite value of x gives me an opposite value of y. The y changed to a negative. Same thing here. Well, when I add an odd to an odd, what do I get? When I add them, still odd. So this is going to be true about evens and odds. But if you're adding, we'll get to multiplication in a second. If I'm adding an even and an odd, or subtracting? Okay? Neither. So if I were to add something like an x squared, and by the way, there's lots of x squareds. I mean, lots of even functions. To an odd like this, plus or minus, if you plug a negative in there, you'll see that it doesn't have, it doesn't end up being the same. If you plug, whatever. It doesn't end up being the same, it just ends up being different. Okay? It's not the opposite, it's not the same, it's just different. One will end up being positive, one ends up being negative, just a different function. Okay? So this is actually neither. Now a lot of people go, man, plugging in negative x and negative y, that's tricky. Well, you know a little cheat? Plug in 2 and negative 2. If I plug in 2 and negative 2 and I get 7 both times, what does that tell me? Even. If I plug in 6 and negative 6 and I get 12 and negative 12, what's that tell me? Odd. And if there's a trig function in there, you probably don't want to do tangent of 5 because you don't know how to do that without a calculator. So pick something you do know the tangent of. What's something you know the tangent of? From the unit circle. Don't use 0, all right? But what's a degree value that you plug in the tangent that gives you a nice, neat answer? 90 gives you undefined.
I'm not thinking very hard.
Huh?
Hole in the cheese.
Hole in the cheese. Hey, listen, open notes, friends taking the test side by side, lots of holes. Okay, remember tangent of 45 was what? Was equal to 1. Tangent puts the y over the x, you put the root 2 over 2 over the root 2 over 2. You might want to brush up on your unit circle. I actually mentioned that in the, I'm not kidding. That's something that we would have had on the summer reading, definitely. And I mentioned that on your video in my squeaky video for tomorrow, because I was doing a couple of function problems and I'm like, I bet they have not looked at the unit circle in a while. And I didn't get to quiz you on it, I don't think, because I was probably doing videos. And I normally quiz you a couple times. We have like races who can do it the fastest correctly, kind of like we did powers quizzes. Yeah, you'll really want to, honestly, guys, review that unit circle, make sure you understand it. When we get to trig, I will, but in the meantime, I'm still going to be randomly it's going to pop up randomly. We will go back over trig, so no worries. We will go back over all of that. You'll see that this year. We'll probably do 67%. Well, this year maybe 50%. 50% of what we've already done, we'll do again this year, and you'll be like, sweet. We might add a little to it, but sometimes we don't even add much at all. Okay? But definitely review the unit circle. But this is true. Now, when it gets to multiplying, things change a little bit. All right? What if I have an even times an even? Think about it. An x squared times 2x to the 4th. What do I end up with? Still an even, right? When you multiply? So something like this, a function that's a even function times an even function, definitely even. And that's also true for multiply and divide. Either one. But here's where it gets different. What if I have an even times an odd? Check it out. X squared times a 3x to the 5th. I get 3x to the 7th. Odd power, right? If I plug in a negative x in there and simplify, I get a negative version of that, which is a negative opposite wise too. So even times an odd, something like this, then we are going to end up with an odd. And then lastly, and that's also true for division. Lastly, what do you think an odd times an odd? Check it out. If I have something like x cubed times an x to the 5th, I'm back to an x to the 8th. Y'all seeing that? So an odd times an odd, and again, same thing with division. That's going to give me an even. Now, most everything else gives you a neither or a who knows. I mean, sometimes you just, like weird stuff like, what's a neither times a neither? And you're like, what do you mean a neither times a neither? Something that is neither even nor odd times something that is neither even nor odd, it might be neither. But guess what? It can also be even. It might even be odd. Like all kinds of weird stuff. Like, what would you say this is? Dang it. Can't work outside the window. Did y'all even get my phone? I think I did a video and I was like, hey guys, everybody text me. And then the people in virtual were like, and I didn't even say my phone number, but I wrote it over there. Whatever. All right, what about like if I said, here's a neither, right? An even plus an odd is neither. What if I divide that by a neither? What do you get? What's a neither divided by a neither? And 1 is what? What's y equals 1? Horizontal line? What kind of symmetry is that? Y-axis symmetry. That's even. But if I change that to this neither, now it doesn't give me 1, does it? Now it ends up giving me, and you'll see that if you just plug a number in, it ends up being neither. So when you start getting the neithers, all bets are off, but guess what? You don't typically get into that much. What you normally get into is the basic stuff like the multiply and the plus and the subtract and the divide. So as long as you know those, you're okay. One other little thing, every now and then they'll do something like this. F of x equals x squared plus 1. Tell me, even or odd? By the way, just look at it individually. What's that? Even power? What's y equals 1? Even. Add 2 evens and you get a even. So we know that this is even. What if I gave you this? What's that? Odd. Okay, here's a little trick. What is, or a little curveball, what is that? A little more confusing, isn't it? Just do it and look at it. How do you do f of g of x? So you take the g of x, there it is, and do what? Plug it in there. So I get x cubed squared plus 1, which gives me x to the 6 plus 1, which is even. So just do the composite function. Don't memorize rules on stuff like that. And if you're not even given the function and they go, hey, if they just say f is even, that's odd, what is this? And you're like, well, how am I supposed to do that if I don't know what the functions are? Make one up. Just go, well, let me see. If f is even and that is odd, and then just do the composite function and take a look at it. So just kind of guess, check, and revise to make it work for you. And the only thing I wanted to do is to emphasize calculators. Who does not have a graphing calculator in here? Raise them high. Who does not? 3. So normally what I would do right now, or maybe tomorrow, is everybody would have their graphing calculators but you 3, and I'd say, hey, come borrow one of mine. I am not allowed to loan them this year. So you guys have to get one. I talked about that yesterday, right? I hate that as a parent. Dude, when a parent goes up and goes, hey, can I have $160? I'm going to go play. I'm like, what? I mean, I hate those questions. It's going to cost you at least $150 for this calculator if you don't have one, and I can't let you borrow one. If you are like, hey, and listen, I get this. My wife is an artist, does very well, but they have canceled like every art show. I mean, she goes to an art show, and on a bad trip, it's $2,000. On a good trip, it's $16,000. You cancel 3 or 4 art shows, it starts making a difference. And some of those people still reach out and buy stuff, but I know, you can't. And she probably does 2 or 3 or 4 a year or something like that. So I understand a financial hit, and we tighten our belt up a little bit. And I got kids in college too right now. So and one that moved back home and is eating my food. Get her out. I know I love my dog, but yeah, I understand that. So if right now you're like, man, we just don't have $150, talk to me and just come see me after school or send me an email, and I'll see what I can do. But you're going to want one of these. Most of you guys are math and science guys. You're going to take this class. You're going to take AP Cal. Very well may have a math or science class in college. The sooner you get to learn these calculators, the better. But I'm going to hold off a little bit. If you happen to, I didn't go back and look through every homework problem I have. I didn't. But if you get one that says, hey, use your calculator for this, just tell me when you come in and say, hey, there were some problems on this, and I'll bookmark it in my head to when everybody gets them, maybe in a week or 2 or whenever they come in. I know Amazon's slow. We'll figure it out, okay? I'm not going to let this world we live in or maybe my failures with technology hurt you. So don't worry about that. I'm a pretty fair guy. We'll figure this out as we go. We good? All right, that's all I have for you. Does anybody, just looking at this line sheet, have any things you want to ask me about? You can just kind of look through questions, and you might see something like, oh crap, what does it mean if it's horizontal or vertical? Or yeah.
I was just wondering, how is it like, how do you have origin symmetry with no X or Y? Is there just like
How do you have origin?
yeah, when there's like not X, like or Y?
Like, so that doesn't have y-axis because there's not this part here, right? So like origin symmetry, that's an example. Sine curve.
So that the top one isn't Y axis.
This?
Yeah.
No, y-axis symmetry would mean opposite x's give me what? Same y's. There would have to be a point there. So this would be y-axis symmetry, but it wouldn't be a function. This would be y-axis symmetry, but then this would not have origin. And there's some that have all three. Who can tell me it's not a function, but who knows a graph that has all three symmetries? Circle at the origin, right? Or an ellipse at the origin. Circle at the origin, like y-axis symmetry, x-axis symmetry, spin at 180, origin symmetry. But those aren't functions, so we probably aren't going to be talking about them a lot in this chapter that's talking about functions. We good? Anybody got any questions before I stop my video? All right. Good chat.
Where is Brandon?